My philosophy on building PHI language is to try and simplify things and to make one process handle everything of a category. And right now, with how it's built, in this little snippet of code here, I have it printing out the hello world with the new line, and then the value 21. And under the hood, and I'll go ahead and run this, and you can see here the hello world and 21 there. And under the hood, how this works is it has a print function for int right here, print int, and a different print function for log, print log. And this is probably not a good idea. So what we're going to do instead, since we have to do it anyways, and we'll go ahead and copy this code, is to do a .toString conversion. So we're going to go ahead and replace all of this with this code. And we're going to get out of here. We don't need this. So to do that, we need sort of a buffer to put the string in. For now, things are going to have to get reorganized and redone. So right now, here's the moving the value, or 21, into the AX register and calling print int. Okay, but also AX is 2 bytes and we'll need 4, so that's another reason to do it. But I'm going to go ahead and run that and make sure it runs. Oh, that's the wrong one. Let's run this after saving it. Make sure it works. Okay, so 21, hello world, good. Now what we need to do is get rid of this printInt function and replace it with a different function. Now I had messed around with this earlier and run into some issues, so I decided that I'd just redo it so that people could see. So we'll go ahead and grab printInt. We're gonna preserve it for now because we might want to reference the original, but we're gonna redo the code in here. So this is gonna change. We don't want, what we want is EAX. We don't want to move a word, we just want to move the value. Let's go ahead and take a look at the value, make sure it's a DD. It is, good, 21. Okay, good. Okay, and instead of calling it print int, we're going to call it convert to string. And then when I call it, we'll just call convert to string. Then we'll move si, and then we'll need a value here, and then we'll call print log. That way, both call the print log, but one of them converts the value first. So this is the conversion code, this is the logging code. And now we need a value to store the converted. So we'll say, we'll call it value. We'll maintain that same convention. And this convention is here because it prevents people from assigning variable names that are things like call, move, jump, so that we don't have any issues with that. So we'll just call this the string buffer or something. And then we'll go ahead and create that. Now, to show an int, I think the value of 4 bytes at max is like 4 billion. So all we need is enough spaces for that value to be included. That should be plenty. It'll just be zeros from now. We can copy that name. Now, at the moment, that's not going to show anything. Okay. If I run it right now, I believe, okay, it'll run the regular old code that prints this stuff out. So we don't need that. We don't want that regular old code. We still need this. I don't think we need that at all. We don't need this. In fact, we don't even need this. What we need here instead is mp done. Actually, it's going to be store value or something like that. I think it'd be store value. Okay, now we don't need all these. Done will just be return. We'll add a label, store value, and we'll move. Okay, so this is division. This is the calling the print in. So this becomes convert to string. And then this is the storing of the value. So that will move into this label. We will not need the int x10 because that's going to be handled by that. We will not need to set this as a type. Okay. So what we need is to move the values into this buffer. So we need a buffer position, just an index. And that can be a byte because this is not going to be longer than an integer value can be. So for now, that's fine. And that's a dB. I got to remember that's a dB because that's the thing that got me last time when I was trying to do this. Turns out moving a single byte into EAX is different than moving it to AL. So because of the position. Okay, so we've restructured this. It divides the number if it's greater, and it goes to store value if it's less than, and then when this finalizes, it'll just go to store value. I believe that's correct. DX, DL, AX. So we need to put this code in here actually because we do need to move it. Let's do that. All this needs to be shift tab. Okay. So we do it here, but we also need to do it in store value, right? Okay, okay, okay. That may be able to be fixed later in order to make it easier. Okay, so what we need to do is we need to have this value deal with AL. And I think we're going to be adding the, so we do add AL 0. So we don't need it here anymore. We just needed that there. Okay. And then we need to move the value from AL into this position of the buffer using this index. So in order to do that, we need to essentially use, it looks like, okay, we didn't use DX. Yeah, okay, BX is here. So we'll use BX. So what we're going to do is do push BX. And then, oh, no, go back. I don't know why Visual Studio went, okay, pop BX. And these are all going to be 4 bytes eventually, so they'll be the EAX instead of, but anyways, that's something that comes a little bit later. So we're pushing BX onto the stack so that we can use it without disrupting whatever current value is. And then we need to move into BX the buffer. Yes, so value string buffer. So this, without the little brackets, is just the direct memory location of it. Okay, so just so you understand. And then we need to move into CL. And CL is the lower byte of the CX register. So we're doing a single byte. So we need value and then index. And this, I believe, needs to be a reference to the actual value and not to the location. And then we need to add 2bx cl, cl, and then that's the location. Now bx becomes the location, which means move, and it's a single byte, bx, into the location referenced by the bx, so the literal value. And we're moving al into there, I believe. And then we got to increment this index. So we increment cl, and then, why does it keep doing that? Okay. And then we move value string index. We move cl into there, and I believe that completes that. Okay, now we can test it. I'm going to need to change these all over to registers that are 4 bytes. Probably not 100% necessary to do this, but all the ones that would be bx, ex, etc. I mean, because an integer is going to be 4 bytes. It's already defined as 4 bytes. We would have an issue if we put a too large a value in, so we better do that. And now I think what we'll do is test this, and we'll need to do it. Okay, so we're going to move the value in. We're going to convert it to a string. We'll print the string buffer. Okay, I think that's kind of what we're supposed to do. Oh, 46, huh? 46. Oh. ECX, I think. Yeah. Nope. So in order to debug, I'm gonna go ahead and convert this to a string format so that we can actually see something printed. Okay, it's just not printing that, so then there's an error. Okay, convert to string. Oh, this is the error. Aha, 21. All right, so let's just go back and undo all this because it's not necessary. And then let's fix that error that we had. Okay, 21. So now we have a toString, convert to string label is what these are called, which are essentially functions or classes. I don't know. It's just a label. It's used similar to a function is used in other languages in assembly. And it works, but we have to reference a very specific value that we use to store it, which is not, that's not the worst thing in the world. There are probably better ways to do this, and I'm going to be improving it. But I think the next video that I'm going to do is going to be taking this code that we have and updating the code I have in the translation project. So I have a C# translator that translates PHI code into assembly. And we're going to be adding this convert to string instead of print int. So, and this should really be called convert int to string. But yes, so that's assembly language. That's deconstructing. Oh. I have it called that somewhere else, don't I? Yes, I do. There we go. So anyways, I'm gonna end the video here.